The Haber process for producing ammonia. The production of ammonia is a very important process as it is used to make fertilizers to grow more food crops. Ammonia is made from hydrogen and nitrogen. Nitrogen, which is removed from the air. Hydrogen made from methane, natural gas. The Haber process is a reversible reaction where both reactants and the products are gases. So here you have N2 plus 3H2 gives you 2NH3. Okay, so N2 plus 3H2, the reversible reaction symbol gives you 2NH3. Nitrogen gas plus hydrogen gas gives you ammonia. So if it's dynamic equilibrium, the rate of reaction going forwards is equal to the rate of reaction going backwards. Forward reaction. Hydrogen and nitrogen make ammonia. It is exothermic. The reverse reaction, ammonia makes hydrogen and nitrogen. Endothermic. Both reactions are happening at once. So how to make most ammonia quickly and cheaply? We can change two conditions inside the reaction vessel, temperature and pressure. If we increase the temperature and if we increase the pressure to 500 atmospheres, right, it can be very expensive. A compromise solution. So it is low enough for a reasonable yield but high enough for a fast reaction. Pressure low enough to not need expensive reinforced apparatus but high enough to give a reasonable yield. So we say about 450 degrees Celsius and 200 atmospheres. The effect of temperature. Because the forward reaction is exothermic, it releases heat, and the percentage yield of ammonia is greater at lower temperatures. The ammonia molecules tend to split up again at higher temperatures. So it would seem that the temperature needs to be low. But low temperatures makes it slow. So you need to wait for a very long time. So a higher temperature 450 is actually used to make the ammonia faster even though the yield is lower. Effect of pressure. So remember, if you increase the pressure, it favors the one with the least moles. So if you increase the pressure, it will favor the right hand side. Because the forward reaction produces a smaller number of molecules, a higher pressure makes a larger yield of ammonia. But using high pressure is expensive and much stronger materials are needed. So we can't use that. We're going to use a compromise. A medium pressure of 200 atmospheres is used. So compromising solution. Low enough for a reasonable yield, but high enough for a fast reaction. Low enough to not need expensive reinforced apparatus, but high enough to give a reasonable yield. You would also need a ion catalyst to speed up the reaction. Although the ion catalyst speeds it up, it can also go back in the other direction. So the ion catalyst can be used to also speed up the reaction further.